now in contact with the sink. Homeowner wants it as close as they can to the front. If you're pushing that thing toward the front, you're hitting that. You're good on top because we're providing this element. Almost all of our bases on our touch products have this feature, this what we call a top hat. So when you put it down in the hole, it goes down and if the edge of the sink's going to be next to the shank, we're going to make sure we insulate. We're preventing point contact. Same thing underneath on these situations. This particular one is a round shank, so we have this round top hat feature. Put this on first. This goes over the shank, goes up. Now if that sink is touching the hole, it's going to hit this edge before it hits my shank. So on these types of brackets, same thing. We're going to put that shank here, we're going to protect it with this non-conductive lip. So in this situation, we would put this on top of that bracket. We know in this particular sink that we don't need it. You can look underneath there, you got that lip is pretty far away. So this is the type of things, and then I were saying use this, use this, use this. But what we want you guys to realize is, well, this is why we need it. These situations, you can get under and you can make your observations. You can determine whether or not you need these. It's not going to hurt to put it in. We always tell you to put the isolators in.
They come with every faucet.
If it needs it, it's going to come with it. With one exception. What we're putting in here is some of our early faucets about 2 years ago. We since have realized, you need this component. You need this insulating component. You need this component. There's actually another component that snaps in here for wire management. Well, let's just do this. Let's make a non-conductive. Oh, and if you're on a metal sink, you need this. So you need all of these. Or you can just do this. Here's your isolator. It's non-conductive. It's 1 inch thick. Here's your top hat features. Here's your wire management. And there's your mounting bracket. So you no longer need all of these components. So all of our new products that have this type of mount and can use this, they're using this. So if you see this in the box and they're concerned that you don't have this in the box, don't be concerned, because here's your isolation, here's your insulation, here's your wire management, and your mounting bracket.
So we're having him install with the old style.
We're going to install with the old style just so we can kind of show you some of the challenges and be able to simulate some stuff. So at this point, we're just going to throw the mounting bracket on and tighten that nut down. And while he's doing that, top mount, we just talked about if this is a drop-in metal sink. Our base has this built-in feature to prevent point contact. You throw it on in a discussion, your sink's down here now, and you just lost that feature. So it'll tell you in the instructions, hey, if you're using the discussion, make sure you also use one of these other elements to prevent that point contact. So it's all about insulation. We're just trying to avoid conductive object contacting conductive object.
If it is touching, and you touch the sink, will it come on?
If you're touching the sink, yes. It could, very well. It depends on some other things. If that's the only thing that occurred during the installation, let's say there's no other issues, very well, yeah, probably that's what's going to occur. If you've done that and there's some other things going on, it just won't do anything. You can't get it to operate, touch isn't working, and you're having to back pedal quite a bit.
How close does it matter when that flange?
Right now, it doesn't matter as long as we're insulated. So this faucet, and I'm going to explain a little bit better. It knows that I'm standing here right now. I'm conductive. It knows I'm standing here. It knows that I'm a lot further away. It knows I'm a lot closer. It knows I'm touching it. It's going to turn on. So it's coupling with me because I'm conductive. If this was a backsplash wall and it had metal here, I'm coupling with it. And what it's essentially doing is anytime I couple with something, I'm becoming less sensitive. So think of the performance of our faucet being perfect, and I have this.
Sounds like a marriage, isn't it?
I have this much sensitivity. This is a mark. I have a level. This is the best sensitivity, and this is I'm not working anymore. If I'm on a non-conductive sink, on a non-conductive countertop, and there's no metal underneath there, no garbage disposal, my plumbing's all plastic, nothing going on here. I'm down here in this level, and the sensitivity is awesome. As soon as I add a metal sink, I lose a little bit of a step. Now I'm this sensitive. So the more metallic stuff that I'm, I can have something metal in here, but if I'm within an inch or two, I'm starting to couple with it, and it's saying, okay, I'm losing a little bit of sensitivity, This electronics was designed to work with this much mass, this much conductive mass. And that's how it calibrates itself. The more conductive stuff I add to it, the less sensitive it's going to become. And eventually it's not going to respond to me touching.
You can see, you would ask the question, I mean, maybe you can't see from over there because of the light in the room. You can see that this piece installed there.
Yeah.
Uh-oh, sorry.
No, go flip it off one more time. If it weren't there, then we would be brass right on that little tiniest of pieces of that metal sink, and that's all it takes, for it to touch that to interfere. So that's why this piece, you can just barely see the outline of the white ring. That's why that piece is in there insulating between those two things touching.
Okay, just one on. So I talked about coupling with things. With capacitance, it's about surface area. If I have something that is a capacitive sensor here, and it's the size of my hand, and I bring another piece that has that much area, I'm going to couple with it really good. If I bring that conductive object and do this, I'm not going to conduct with it very good because it's just a very small amount of area. So that's why we don't really need isolation at that point, because that's just a very small area that it's next to, not very important. If I was on a metal sink, now I'm coupling with a large metal area. That's when we want to put that isolation in. So it's all about how much area am I exposed to. If it's just a point like we have right there, I'm not worried about isolation. I'm only worried about insulation. That was quick. Don't you wish every cabinet that you go install, you just pull it out, flip it around? So at this point, I think the instructions, we're at the hose. Now this one's been pre-installed, so we're gonna help it out. A lot easier to put that sprayer in with this off, right? You guys are like, how'd you do that so fast? It never works like that. Oh, wrong way.
It's always fun to get in without the little penis head thing. That's the technical term. Yeah, it's very technical. That's what I just said there. Damn me if you don't sit down there, I'm gonna sit there.
Okay, at this point, once the electronics module, and we're going to attach it to that swing clip that we pre-installed with this quick connect clip. We call this a Bono clip, and there's extra credit if anybody can figure out why we call that a Bono clip. Do you know what we call a Bono clip?
So you tune on it? I don't count, right? I can't answer the
This
question.
is the Sonny Bono after you hit the tree.
That wasn't funny.
We don't need the ladies trying to tell the story sad too.
Yeah.
Joe Walsh, 2000.
All the women in the room.
Yeah.
First try, I got it.
Yep. Any date at the
Yeah,
time.
how many times is that going on?
Okay, now we're going to connect
Get hose weight.
the alarm. So we have the bullet in there, which helps
Oh,
guide
you
that
did
hose
have
down
that.
there. You guys feed hoses through
Let's
there.
see.
That bullet's a pretty good thing, right?
It sure helps.
So this is, you remember the weight? Sometimes the weight gets forgotten.
Spencer, do we put the weight on every pull down faucet in Breezum Delta?
Yes,
Yes.
always.
We do, okay.
It is always optional. It works fine without. A lot of it also depends on what you got going on underneath there.
Exactly right.
Because we know when you pull hoses out, there's not a lot going on. It's free to move, but when there's supply line to your RO, so waste line to your RO, your dishwasher discharge.
Oh, you mean like the 36-inch ones over there?
Or the two cold angle stops and the two hot angle stops.
Brought back to the law.
Something about the other crap they call it.
Alright, so now we're at the electronics, so it's asking us to hook that clip, so that hook, this is our sense line, so this is the element that will hook to the conductive shank. There should be a groove at the bottom of the shank, and
Does the weight affect
Hi, DJ.
the touch?
it does not. It's far enough down, and it never will go up above the bottom of that electronics pack.
But when you pull it down, does it affect it? It's not broken?
That's what I was gonna say, the claw of that.
Alright, so I talked about, this bracket has this wire management feature, so it's saying, hey, take these wires now, and I'm gonna show you in a minute why it's important. And let's hook one of this black wire coming out, let's hook it over here, and that sense wire coming up, let's hook it over here, let's keep them separated. That's what those are for, and I recommend using it. In this bracket, there's actually a couple elements that they weren't in the bag, you actually push them up in there and it has those hooks. We're just gonna leave it out because I'm gonna take them out of there in a minute anyway. So at this point, we would do the wire management. Next thing would be take that LED wire, it looks like the stereo jack, and it plugs in here to the bottom side. Now this one, it takes a little bit of extra force to actually get to see good. We actually get a few calls where they're having some funny things going on with their LED light. It's because that's not plugged in all the way, and it'll give you some different lights sporadically during operation. So now we're ready for the battery pack. And there it is. And so we always recommend just on the floor and 2 inches away from anything conductive in the edges, because we don't know what's going on. Is it a plaster wall in the corner, and is there a metal lathe in there? Who knows?
There was a lot of discussion yesterday about it's wet down there, I've got chemicals, I got all this, and it's okay to put it into a non-metallic container, you know, butter dish, whatever, something like that's okay.
Ziploc bag, Ziploc bag.
That'll work.
Yeah, as long as it's down on the floor.
I got a question. I had an installation I could just never get right, and it was because the contractor had laid literally a shower pan, if you will, of aluminum all along the bottom, so if they ever had a flood, it would come running out.
That's just.
So at that point, that's going to be a little bit tricky. Well, I would recommend, if you can't convince the customer to give you some non-shower pan space under there, get something non-conductive on the bottom of that shower pan.
Okay, so
And get it away from the edges of the shower pan. Just try to get it
how far up? An inch?
2 inches.
2 inches, okay.
So all we have left is the supply lines. And you'll notice the check valves are already installed on this particular model, but check valves are important because the operation of this faucet is you leave the handle open. So this is a standard valve. This is our standard DST cartridge. And now the hot and cold ports are open to each other, and if I have a recirc pump or uneven pressures, I'm putting hot water in my cold line or cold water in my hot line. So we're going to prevent that with these check valves. So
What
as
have you guys been instructed to put these on? How do you put this on? You guys have installed it?
how tight?
How tight was it? Hand tight, one turn?
Different feel, probably.
For feel.
Okay.
Okay, so
You
you're
don't
just
I don't over, you don't over tighten them.
right.
So hand tight, maybe 1 to 2 turns or one,
Yeah,
okay.
and then if it leaks, we can go a little bit more.
Snug it up, okay.
So as we finish this part up, one of the things we wanted to make sure we address is some of you guys have had experiences in the past where you've spent that extra 30, 40 minutes trying to figure something out. You put it on and it's just not working right. And maybe you did something and it fixed it and you don't understand why. Is there any stories and experiences? Nothing. Hey, everything's great, huh? We're out here wasting our time. There's no problem with touch faucets.
Part of it is the battery pack location. I mean, when you get like housekeepers and whatnot,
Right.
moving crap around there,
Exactly.
and everything else. I've gotten a couple callbacks and it was just like they tucked it off in a corner, and one of them threw it behind the the melamine, there's like a little cutout in the melamine.
It's gone.
I just
Is that
threw it,
why?
I'm like, what the hell is this battery pack? Dude, they shoved it right through a cutout that was going to an electrical outlet, but there's this much room behind the back of it, and just, they're like, out of sight, out of mind.
I've seen underneath sinks where they have an electrical outlet underneath it. And people have, I'll put it on top of the electrical outlet to keep it out of the way. And that's just not good.
I've had it where the cable tied it to
So-
the dirty arm, you know?
So this is a common thing we've heard throughout our sessions here. Let the battery pack, it's touch sensitive and it's critical where it's at. Like, you put it where it needs to go and you come back and it's moved or you can't leave it where you want it because the homeowner's pretty insistent. I don't want it there. I want it somewhere else. Good news is we hear that and we're trying to address it. We're trying to do some things a little bit different. We realize that the water's on the bottom and you don't want to put that down there for corrosive elements. So we are going to in our future generations do something with a sealed battery pack. So that is coming. And I know ideally we eventually want to get it up off the floor. We want to be able to put it up somewhere else. And just a little sneak peek over here. This is another electronic product. You see that we're able to do it on this one. We know it's important, and we implemented that here. Let's get this one up off the floor because we can with this
What I was
product.
gonna ask about that one is what about just a clip location so you can actually mount the clip, put the battery back in it, and
Like a Velcro.
it's non-moved. You know?
Yeah, so you know, early on we put some Velcro in there, and we said, hey, put the Velcro on the side, just stick it over here, and we know that there's some certain situations, there's a lot of stuff going on there. We need as much as we can with some gaining more of this window back. The lower you get that to earth ground, the more you're gonna get back. So, and not in all situations you need it. There's some situations where, yeah, honestly, if you're on a non-conductive sink, nothing conductive around here, you can take that battery pack and super glue it to the top of the countertop if you want.
But also behind the wall, it could be 110 volt lines.
Yeah, but don't put it in a hole that you don't know what's going on back there.
Spencer, what if you just, just a thought, ran a lead down? You could put it up here and just have a ground lead go down.
Well, it's all about surface area. So I talked about surface area is coupling. So our battery pack is coupling with earth ground. We would actually get better performance if we laid that on the side. And there's more of those 3 cells of battery that is coupling with ground better, but we don't want to do that because then people, that's just something that
You know water.
you get a lot of feedback.
Right, yeah.
No, we're not going to do that.
Well, you
All right,
don't
so-
have access to change the batteries.
It looks like we're good. What we're going to do is we're going to swing this around so that we can watch it operate. I'm going to hook the computer up to it. We're going to see what that looks like over here. I'll show you another picture too before we go to that screen. These are some of the challenges I hear you guys are dealing
Is
with
it good?
out here. We got a chiller. We got a huge garbage disposal. We've got, looks like some water filtration. That might be an instant hot water heater over here, not sure. Look at these things. Just straight.
That's somebody's house.
Just a,
Seriously.
this thing is, look how deep that is. And we have copper
They
conductive
don't even have
drains.
room for their cleaning products.
So not only, if we are coupling, this shank is probably this close to that sink.
Exactly.
We're not only coupling with that sink, we're coupling with that drain because it's connected to that sink. And that drain is connected to whatever else it's going to in the house as far as the sewage. It might be conducting with the manhole cover outside. So as far as we can get away from the edge of that sink, we need to get. You'll notice our solenoid, it has a metallic portion to it. It's touch sensitive. It's involved in electronics. It's coupling with electronics. So I can rotate that. My sink's right there. I can rotate that out of the way. Let's get that as far away from that conductive object as I can. That's going to help you get a little bit more of this window back. So I think we're ready to swing this around. We'll kind of try to put it up here. I want you guys to be able to get behind it and see what I'm doing and how it's affecting the performance. Right behind.
Here. There we go.
So first thing I'm going to do, I'm just going to do a quick performance check. one of the things that we wanted to try to do for our folks that are answering phones, for people that are having problems, is provide them with some sort of diagnostics that they could use. And what made sense in the beginning is like, yeah, let's give them a fault tree. All right, is your faucet doing this? Yes or no? No. All right, is it doing this? And it kind of leads you in a path to help answer their question. We couldn't do that with this faucet. There's too many elements that will affect. Oh, do you have a garbage disposal? Do you have metal pipes? Oh, do you have a chiller? So there's too many things that can stack up. So what we found most effective was, let's just try to educate. Let's try to teach people how the technology works, how it couples with metallic objects, how it is sensitive and why it's sensitive to battery location. And one of the things we decided to do was create this little sheet on page 7. It's basically a test. First thing you should do when you go to a customer's house is, let's just understand. They call me because there's a problem. Let's understand how it's working. So the way the faucet's supposed to work is, I should be able to walk up, do a valve body grab. This is the valve body, this is the handle. I would want to grab this portion. It should turn on. It did. I should be able to grab the handle. It turns on, and it did. I should be able to tap this valve. It turns on, it did. Things working great. Why'd you call me? No problems. But more likely, they call you because there's a problem. So if something didn't work, this is going to kind of help. Hey, here's what I did, and this is what the result I didn't get. Here's some X's in here. You probably have an insulation issue. You might have an isolation issue. You have a handle wire spring issue. So what that one means is this is a moving object, right? It's not directly connected to this valve body. If it was, I'd be grinding metal on metal. So what we end up doing is, we take this handle and we have it contact this metallic stem of our cartridge, and that metallic stem is contacting this spring, which is contacting this conductive chrome. So that's how we're directly connecting all those elements together. So if I come up here and this turns it on, I grab this and it doesn't, I've got something going on with that spring. It's either missing, it's broke, something's going on with that spring. Now what I'm going to show you is what we use to help us develop this product and also help troubleshoot this product. And it's going to give you that sneak peek that I call the Wizard of Oz behind the curtain stuff.
While he's doing that, guys, I want to point out on this troubleshooting guide that Spencer put together on page 4, he alluded to a point earlier that we provide the isolation and insulation components in there, but you're going to notice on page 4 that there's some situations where he said you don't need those components. This is probably going to be a little contradictory to what the M&I says in some situations. It's always going to tell you to put all those components in there. And that's fine. That's fine. It won't hurt to put them in there. What Spencer's saying is that may not be the issue that you left that component out, okay? So he's giving you a guide here to say, for the particular sink application or the install, you may not need that component. That's not the problem.
We don't want you to get into what we mistakenly did. We preached to our people on the phone, hey, you gotta have this, you gotta have this, you gotta have this. We tell it in our literature, you gotta put this in. You go to somebody's house and they're having a problem, I don't want you to automatically look at it and they're not see this and say, that's your problem, we gotta take your faucet off. Hey, they're on a non-conductive sink, there's nothing conductive under it, that's not their problem. I know we want them to put it in, but it might not necessarily be the problem. Think about the other things. So what you see up here is this is like a oscilloscope. We call it touch 2 oscilloscope. It's